of the domain because I have to put it in the table. So looking at this function, what would you do first? Right away. Without which we cannot determine the domain. Yes, I'm ready.
We have to factor the bottom.
Absolutely. Thank you. Perfect. Let's factor the denominator. Very good. Excellent. Can anyone factor the denominator for us, please?
Is it x minus 3x plus 7?
Excellent. So can anyone give us a domain now? Anything but?
Anything?
-7 and 3.
Yes. -7, 0, 3, infinity. Is it type 1 or type 2? Type 1 or type 2?
Will it be type 2?
Yes. Perfect. What is the end behavior and the horizontal asymptote then? It's the easiest one. I don't have to calculate anything.
Negative infinity, infinity.
Careful. Horizontal asymptote is 0 when the numerator is weaker than the denominator. So y equals 0, horizontal asymptote. Okay, now I'm going to uncover this and I'm going to ask you what is next. What do I have to do next? Very important to notice.
Is it something with both the x plus 7s?
Of course. Of course. What does this mean about x equals -7? And what does this mean about x equals 3?
Would be -7 would be undefined.
They're both undefined. The factor that disappears creates a hole. The factor that stays is a vertical asymptote. The factor that goes away, the function is still undefined in both. There is no discussion. We are graphing the original function. So the original function is undefined at -3 and -7 and 3, but because the factor of x plus 7 went away, that is a hole in the graph. The factor that stays is a vertical asymptote. Good. So now, the simplified form, I'll come back because we know that the vertical asymptote here has infinities left and right. But what we don't know is the sign. So we have to try 2.9 and we have to try 3.1. We know that with -7, I have to plug it in, but let me write the function, the simplified form first before we continue. So now the function is very nice and easy. So in order to get the numbers left and right, I have to plug in -7. -7 minus 3 is -10, 1 over -10, with minus in other words, minus in front. 1 over 10. Very difficult to plot something like this. How do I plot -7, comma -1 over 10? We'll make it happen, no worries. Okay, then I have to plug in 0, and I get negative 1/3. 0 minus 3 is negative 3, negative 1/3. And now I need to find the signs of infinities. Can you please plug in here 2.9 and tell me the sign, and then plug in 3.1 and tell me the sign. Just the sign.
2.9 is negative.
Yes, of course. And on the other side is positive. Very good. That's all we need. Done. So I'm going to use just the table. Nothing else is important. Nothing else matters. And graph the function. When we graph a function with asymptotes, we have to graph the asymptotes first. So one asymptote is y equals 0. It's an overkill. It's already there. The other one is at 3. And I know at negative 7, 1, 2, 3, 4, 5, 6, 7 is negative 1/10. So I'm ready to graph. And 0, negative 1/3. It's very big by comparison to this. It has to be, because this is my negative 1/10. Of course it's not. So that's why this one is negative 1/3. Okay, I'm ready to graph. From approaching 0, going through the hole, crossing at 0, negative 1/3, going to negative infinity on the left-hand side of the asymptote. Quite easy. Again, from approaching 0, going through the hole at negative 7, crossing the y-axis at 0, negative 1/3, and going towards negative infinity. Always decreasing, 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 decreasing. On the other side of the vertical asymptote, it's coming from positive infinity, decreasing towards 0. From positive infinity, decreasing towards 0. Which function did we graph? We graph f of x plus 7 over x squared plus 4x minus 21. Yes, I will check if you want to check with your calculator. We can. And we enter, be very careful how you enter it in the graphing calculator. With parentheses for the top, x plus 7 divided by, in parentheses, x squared plus 4x minus 21. There is no point in entering y equals 0 because it's already the x-axis. If the horizontal asymptote were y equals 5, then I would have had to put it in. But there is no need here. Now, I will use the standard viewing window. If I need to zoom in to see that hole, I can. So I will use Zoom 6 standard. And here it is. The calculator is not telling us what we want to see, which is at negative 7. So 2, 4, 6, 7 right here. There is a blip, and it doesn't show. So I will change the viewing window between negative 10 and negative 6. I have to find have y minimum very tiny, a negative 0.2 to see the blip, and y maximum 2. And now it will show. Here it is, right here. So maybe I should have I should have gone maybe to -1. Let's see if it shows better. Yeah. Okay, so we see the little hole in the graph. Very good pick. Thank you. It was a good one. Good. Next question. So this was a rational function with a graph. And we can select one with a slant asymptote and calculate the slant asymptote using synthetic division or long division. So if that's what you want to do, what is the next topic? What would you like to continue with? So that was the rational function with a graph. What do we continue with, please?
Can we move on to number 4?
Number 4. The polynomial and rational inequalities? Oh, sure. Okay, so that is the last section 3.6. Let me look at the page number 443. Perfect. Poly and rational inequalities. Excellent. Choose anything you want. From 17 through 60. Anything you want. I want to choose one. I think it's my turn. 36. And 36 on page 443. And we have x cubed plus 7x squared minus x minus 7 less than 0. A long time ago, we learned how to deal with 4 terms. So what do I have to do with 4 terms? What is my thought? What is the process called? Because I need to factor. If I don't have it factored, I can't use the table.
Did you factor by grouping?
Excellent. Very good. Thank you very much. Okay. What will you factor out from the first 2?
X squared,
Very good. What is left?
x plus 7,
What should I have coming out from the other 2? Otherwise, I can't continue.
x plus 7.
Indeed. Otherwise, I can't continue. Factor, sign, and factor.
-1,
Indeed. Good. What comes out now from these 2 terms? What is common to these 2 terms?
x plus 7,
Very good. What is left?
x squared minus 1,
Good. How do I factor x squared minus 1? Anyone, please? How do we factor x squared minus 1? Anyone with me, please?
Is it just x minus 1, x plus 1?
Very good. Finally, I can use the table. It's all factored, everything on one side, and 0 on the other. So, x is the variable in the problem. X plus 7 is the first factor. X minus 1 is the next factor. X plus 1 is the next factor. And now I want the product. X plus 7, x plus 1, x minus 1. This is what I'm interested in. X can be anything. I need to know when this is 0, when this is 0, when this is 0, and put the numbers up here in the correct ascending order. Which numbers will you give?
-7, -1, and 1.
Excellent. -7, -1, and 1. -7 with -1 and with +1. When any of these is 0, the product is 0. Now I need the sign. But it happens that all these are linear functions with a positive slope.
Negative to positive.
All of them. Negative till they get to 0 and then positive. Negative till they get to 0 and then positive. I'm multiplying 3 negatives.
It would be a negative.
I'm multiplying 2 negatives. I'm multiplying 1 negative and no negatives. Only now I look here. Well, they want negative because only negative is less than 0. Is the product ever negative? Yes. Since there is no equal symbol, negative infinity, -7, union, -1, 1. This is like a puzzle, really. Any questions? Do we need another? I chose this one, 38. Do we need another example?
Can we do 40 as well?
Sure. Very good. So let's look at 40. And 40 is x cubed minus x squared plus 9x minus 9 greater than 0. Good. So how do we continue? Anyone, please?
X squared. X minus 1.
Good.
It's also x minus 1.
Yes.
And we pull out the 9.
Yes. And positive 9. Very good. So I factor out x minus 1, and I have x squared plus 9. This is always positive. I don't have to worry about it at all. I can simply disregard it. A quantity that is always positive is not going to have any effect on anything. So x greater than 1. This is it. So 1 to infinity. There is nothing I can write about that. So x squared plus 9 is always positive. Therefore, it doesn't have anything to say. It will not have any effect on anything.
So when it's like that, the table is not needed.
If I have one in the table and like this one here and everything else is positive, it will not count. Because the positive, see, I never even look at positives. I say how many negatives? Negative. How many negatives? 2. How many negatives? 1. No negatives. So only the negative sign will change will have an impact on the final answer. The positive sign will never have any impact. So for this quantity to be positive, this has to be positive, because this is already positive, always. Only when I multiply two positives, I get a positive. If this is negative, then it's not good. A negative times a positive is not a number greater than 0.